Hello everyone, my name is Hisham. I'm the owner of Clemson Aeronautics, where we make the riveting and dimpling systems. And this video is number 5 for the elevator, and we're starting our scuffing of the upper skin. And what I done in the last video, I talked about the place where the foam ribs is gonna be, and maybe I can show you where I marked it. I don't know, can you guys see the line? I made a couple of lines on there with my marker. It's not very heavy, but the part that I wanted to point out at is those holes is going to be riveted to the rear spar, and the two skins is going to be together after that, and there will be just a little opening here that we're going to go in and rivet it from. I used the dimensions to locate where the rib is going to be, and I positioned my marks right in between two holes so I can have access to these holes when I rivet them. So that's the number one issue. Now we can scuff, bearing in mind that. So what I'm going to do is I'm going to scuff where the holes is going to be, to deburr the holes and at the same time scuff it so the paint will stick really good to it. I'm not going to try and scuff the rest of it. The primer that I'm using, that I got from Home Depot, or you can get it from Home Depot or Lowe's, is self-etching. So I'm just going to scuff where the holes are to deburr it and scuff it at the same time, add a little bit of protection so we can have just a little barrier between the ribs and the skin where they meet, and also where the foam ribs is going to be. I'm going to scuff that too. Bear in mind, you have to be somewhat gentle because you don't want to take that layer of clad off. That's what's keeping the skin from corroding. I just finished scuffing my left top skin, and what I done, just so you guys know the way I do it, is I cut the Scotch-Brite pad in half. I get a little piece of wood that I have, you can tell, then I'll put it inside the Scotch-Brite like that, and I'll fold it like this. Now I have something to scuff it with kind of easily, and it's kind of limited in space so I don't go way overboard. You can tell here the area where the foam ribs is going to be, I scuffed that really nice. The trailing edge is really nice, and of course around all the holes, which not only scuffed it, it deburred the hole too. It's very nice and smooth holes now. So the right skin will be practically the same thing, and I'll measure where the foam ribs is gonna be. I'm gonna mark them with my marker, maybe a little thicker than this one. This I could hardly see it, but anyhow, and we scuff it the same way, the trailing edge the same way, except it goes all the way to the end of the skin. Then we're gonna be ready for the next step. And now we need to do an important chore here. The trailing edge, this is the wedge for the trailing edge, and obviously it is steeper towards the inside. So when the trailing edge is laying on top of the wedge, it's just two flat pieces, and we're going to rivet them that way. So I want to put a break towards the wedge, a small break, and this is what we're going to do with this tool right here. And we have to be careful very tiny little break, and this is all what we're after, just to make sure that it lays flat on top of the wedge. The trailing edge worked out really nice, have a nice break to it, and as I mentioned before, I decided I'm going to do that break before I dimple, so that break will stay there when I dimple. The front of the top skins, both left and right, need to have a good break on it also. In the book it says slight break. My experience with the rudder tells me put a really nice break onto it, because the whole thing kind of curves a little bit. So it's not very heavy break, but a very noticeable break. And this is what we're going to try to do here. And by the way, the top skin gets the break, the bottom skins don't get the break. And that's what the book says, because the top is the one that falls over the bottom. The bottom is going to be laying flat on the top skin when they meet together. There you go, folks. Nice break. I can actually realize, I don't know if you can see it in the video or not, but it is a nice break towards the inside of the elevator. And now it is time to do the top right elevator skin, and as I mentioned, I'm using the Scotch-Brite and just a little bitty stick. Now I have to put the brake on the skin, and this is not the correct side, so I have to do it like that, so it would fold inside. That was the front edge. Now the trailing edge is supposed to be just a light break. not as good as I would have liked it to be. Well, folks, there is a customer, actually a potential customer, that called me one time, and he said he's from New York, and he's getting a kid soon, and he likes our system and stuff like that, and he's coming down to South Carolina, very close to where we at, only an hour drive, and he's coming down for business, his wife's business. There's a show and stuff like that, and he's coming down with her with the I don't know, motorhome or something. But he said he wanted to come and visit, look at the place, and buy the system. Then he made a comment, and I'm glad he did that because it clarifies some things and it lets me know what you guys think, so I can answer some unasked questions. He says, you know what, I have no doubt that the weld that you have on your machine is strong and everything, but it really looks very bad. And he used a word to really emphasize the word bad. And I told him, this is my machine, not the machine that I sent to you guys. And actually, this is my machine. I welded that. I'm not a professional welder. And I do that in the R&D process, you know, to weld something and test it and all that stuff. Now, the weld is very strong. It doesn't look good because I am not a professional, but it's very strong, and it does the job for me. Because in the R&D, I can't wait on the welder to come in, and I cannot afford a welder that is good full time on the staff. So I hire a very good welder that welds all the R&D stuff for Clemson University, and they call him up at Duke Energy, the nuclear power plant, to do specific welds and stuff like that. And I was lucky enough because he just liked us, and he likes what we do, and it's somewhat challenging because keeping the tolerance and stuff like that is a challenge for him, and at the same time making some money. And it's easy for him. He just pulls his trailer inside the shop and he does the welding for me and go home. He does very well. Now, just to let you guys know, this is my machine. The weld doesn't look very nice, okay, but it's very strong. Now, the weld on the machine that you would be getting would be something like this. This is a very professional welder. So my point is, and I'm glad this gentleman had made this comment so I could answer that unasked question that probably some of you out there might have, and might not want to buy our system thinking that this is a bad weld and it's not going to hold. No, you know, even the weld that's very bad that I did holds very well. This is my machine. That's why you have tape on it and all kinds of stuff. It's just the research part of it. So, but he never did show up, and he never did come to get his machine. And if you're out there and you're listening to me, please call me so you can buy a machine, because you never know what's going to happen. And this machine will save you, definitely save you a lot of time and a lot of effort. and it will do things for you that is not possible with our competitor with the manual machine, which is riveting, which you are going to see with the rudder here, like you have seen. I'm sorry, with the elevator here, you're going to see more riveting with the elevator system here, like you have seen with the rudder. And one more thing, a lot of my customers has been asking me the table that I have for my system. Obviously my system is you can move it, and that's one of the unique things about our system. Makes it a lot easier, and you're gonna see that over here when we're dimpling the skin right here, how easy it is and to work with and just to organize everything. So the table. So let's look at the table, guys, and I want to put a tape measure in there so people would see everything that I've done with that table. Okay, guys, I guess you guys can review the tape. This is the way the table look. These are 2x4s right here. This is one 2x4. This is the other 2x4 is with an angle. Going down on the bottom right here are 2x4s also, and these also are 2x4, the down top and the bottom. Now, as far as dimensions is concerned, so you guys, this is just a sheet of plywood, and I think it's 3/4 of an inch. I got that on a deal, pieces, great material, whatever, or it was left over from something, so I used that as the top for me. So this dimension right here is exactly 24 inches. So the top of the table is 24 inches, and the width of the table is 9.5 inches. So this is as far as the width and so forth. And the height from the ground all the way to the top, it came up to 36 5/8. Now you guys can make it the height that you want that matches your table. This right here, from the top of that 2x4 to the top of the plywood, is 31 inches. So it was actually, yeah. So these 2x4s, the feet was 30.25. And one customer also made the point that he wants the machine level. So I told him the secret in making it level is to cut all 4 legs at the same time. So how do you do that? I think the best way to do that, because I have a table with a miter saw, best thing to do is cut the legs, the 2x4s, close to that 30.25 inch, and then just screw them with long screws all together, so they are bolted together really with screws. So there is nothing in the way like clamps or anything. Then you take one end and you go with the miter saw, cut all 4 at the same time from both ends. Make sure it's really a 90-degree cut and so forth. So all 4 legs would come out identical. Then you unscrew the screws and then you build your table from that. and you get you 4 swivel wheels, all 4 of them swivels, and you put them on the bottom and you have that. And then like you see right here, the table will move. So while I'm working, I can maneuver my material, so I can be out a little bit, I can be in a little bit. But if this machine is very close to the edge over here, then I have to have the material flying in the air. So why do I have a table? It's kind of ridiculous. But with this system here, you can move the machine and move your material, and you can come literally almost all the way in here to do your dimpling and riveting and so forth. So that's the unique feature of this machine, that it moves and the table stays steady, and you can move your work over the table. Okay folks, let's do something that is very important. Learn how to set up the machine. I got a lot of calls from customers that they want a review on how to set up the machine. The first thing that we have to do in the machine, we're gonna make sure this plate is loose. Both screws are loose. The second thing we are going to do is we are going to disconnect the air from the system. So this have no possibility of working and hurting myself. Third thing, I'm gonna remove the forward pin that holds this squeezer in place, and I'm just gonna tilt this back and let it sit on the machine. Third thing, I'm gonna make sure that the shaft is sticking out just a little bit here, like a little part of the round is sticking out of there, and I'll just mark the flat with the marker here. The fourth step is to get a riveting die, a flat one, and just put it at the end of the squeezer pin. 5, I'll put the squeezer back in place and put the pin back in place, and now we are ready. The squeezer position, as far as the pin is concerned, is ready. So I guess I spoke too soon when I said we're ready. We still have to adjust this height, but at this point I'm gonna plug the air back in to show you guys what I am trying to say. Here there is a little gap between the bottom of the riveting pin or the riveting die and this flat here, and I put this tape here just as a protector. So now if I pull the trigger, you see the riveting die moves down first to meet the shaft, and that's what we're after. Why do we have to have that? Because the springs push the shaft back up at the end of the riveting or dimpling cycle, and when it comes back up, it comes back flying. When it comes back flying like that, it have to come to a stop. That's why we have these nuts here to adjust that. So the shaft stops before the pin of the squeezer stops. There is a gap. Why? Because we don't want to be hammering the squeezer pin back into the squeezer and hit it like a hammer. That's why we have these bolts that stops it before it comes to a complete stop inside, so no damage would happen to the squeezer. Now it's time to set up how far I'm gonna stick out this pin that holds my dimpling die. So what I do, and I just want to make sure everybody know, this plate is still loose, and we want it that way, because if they are not aligned together perfectly and this comes down, it will bend the pin on the dimpling die. So we want it free. And what's going to happen is, what we want to do, and you can see it here, I'm pulling the trigger. It comes down. Now, it's still loose. What I want to do now is I want to rotate this pin till it stops. Then I'm gonna pull this nut all the way up, just finger tight. Then I'm gonna let go with it. Then I am gonna go unscrew half a turn. So let's say this is it right here. I'm gonna go half a turn. Now I'm gonna tighten this nut, and I'm going to use a 5/8 wrench. Just, you don't have to put Arnold Schwarzenegger's or Sylvester Stallone's grip on it or anything. It's just a little tight that to hold it in place. Now I have this height perfect. So let's see, let's just test it before we tighten that up. I am going to pull the trigger. Guys, notice the height here. This part will go up just a little bit. That means I'm squeezing this. Now, when I put material, this material is 16 thousandths thick, it will squeeze it even a little bit more. That's why we do that half turn extra to unscrew it. That means that the pin would come out half a turn. Now we have the squeezing distance is perfect. Now we want to make sure that the two dies are aligned right perfectly on top of each other, and tighten it down. Okay, now what I'm gonna do is gonna pull the trigger again. The dies will come on each other. I just want to make sure when it comes down, the top one didn't have to move this way or this way or this way to align itself with the bottom one. So that's why I have to do it several times and look. Yeah, you see it moved this way a little bit, so I'm gonna move it. This is almost perfect. So it's not moving. So I'm holding the trigger now. This is held into place very tight by this pin. And I'm gonna take my wrench. I'm gonna tighten this screw right here, and this screw right here, and here, here. Now let's test it. It comes straight down. Perfect. So the objective of all of this is to be able to place this die directly underneath this guy with the perfect stroke. And I think we just achieved that. And now we're gonna start dimpling the skin, the left top elevator skin. I'm gonna do all the number 40 holes with the exception of the trailing edge. That we're gonna use another method to do. And this is pretty much the left top skin, all the number 40 holes with the exception of the trailing edge. I was taking my time, making sure that the sheet is nice and flat, it's not gonna jump out of there and I'm gonna do something to ruin it. So that is my idea of being safe. Now I checked all the holes to make sure I didn't miss any, and I actually checked it with a rivet to make sure that the dimple is okay. And now what's left with this upper skins on both sides is the trailing edge, and also on the left upper skin, that little angle piece need to be dimpled for a pull rivet. So that's gonna be a little tricky because I don't have the dimple die for that. It's a 120-degree dimple. So we'll see if we can work our way through this one. And now it's time to dimple the trailing edge of the skins of the elevator. I got my squeezer here, and I have mentioned in before that you have to use the special dimpling die that is kind of ground with an angle, so you don't ruin the trailing edge because it have an angle this way. And since we already done a break in the trailing edge this way, I decided I'm gonna also use the reduced diameter female dimpling die on the bottom over here. Now the male will always go from the outside. So how do we set up? Just as a review, I put the dies in, pull the trigger, you can tell it is free to move. I tighten it all the way till it's tight. I have a mark over here. So what I'm gonna do is I'm gonna turn it outside half a turn. So now I think I'm gonna add another quarter of a turn. So now it is ready. I know I got a good spring back here. When we add the thickness of the material, it also should dimple it really well. So the female die is from the outside. I set the material with an angle, and actually looks pretty good. Let's get a rivet and check it out. So I checked it out with a rivet. Dimple looks pretty good. I'm just gonna go ahead and do the rest of the holes, and I'll be back for another trick that we need to use on another set of holes. One more thing that I wanted to mention. I have it set up where the material is kind of flopping around, so it would center itself up. It bends a little bit, goes this a little bit, so when the dies compress, it positions itself perfectly where the material is level in between the two dies. Well, folks, I don't have the dimple die for this one here, and this is actually the rivet. I had to dig pretty deep in the manual and spend a whole lot of time just trying to figure out that it's a CS4-4 rivets, and I don't have the die for it. And as I recall, I looked for it, I couldn't find it. But anyhow, and what I had rigged in the past is this. Made a plate and drilled a hole through it, got a rivet and chopped it in half, and what I done is I put it in here in my rivet squeezer, and I used the number 30 die to squeeze it in. But at the same time, I can't squeeze it too much because it makes the hole a lot bigger and so forth. And the other issue is this shear clip here is pretty thick. To do it with this this rig that I made, it did not phase it. It just put a little bit of dent in it. So what I done is I put my number 30 in there, and this is just my preference, and I pulled it all the way in. Then I started squeezing just a little bit at the time to start the dimple here, and I checked it each time with the rivet till I made sure it's flush, and I closed it at that. But I know this is not kosher, but this is all I have now. So I finished that. Next step is to go ahead and prime the skins, then jump on the other parts and start disassembling the rest of the elevators, priming them and marking them and so forth. I'm gonna go ahead and close the video at that. It's pretty long as is. Thank you very much for watching, and we'll see you next time.